Always a good day when some PCBWay boards arrive. First because of the swag, which keeps getting more swaggy, and then because I'll be able to finish that project. That's a board that I designed for the modem in that teletype, which used to be Telex, and I want it to be RTTY. Hello, today we are going to amuse ourselves with the descendant of the baudot teletypes, which is this 3M Whisper Writer machine. And this actually was a Telex machine, which you could connect to your phone line using this box from Western Union. So that's how you would text back in the day. But instead of being on a clunky teletype, you have this beautiful, modern, silent thermal teletype. Hello and welcome back. If you follow the channel, you have already seen us play with a similar machine, the Texas Instruments Silent 703. Same idea, this was a modern replacement for the ASR33 teletype, and it made for a much nicer computer terminal. The big difference here is that the TI unit uses the semi-modern 7-bit ASCII encoding, whereas the 3M Telex terminal uses the profoundly ancient 5-bit baudot encoding, the original encoding for digital communications from the 1930s. Which of course we count as a plus, as we will be able to interconnect it with our real baudot teletypes. Indeed, the goal is to use it as a test machine for my older teletypes, as well as a convenient radio teletype for over-the-air teletyping. By the way, this Telex machine is yet another donation to the channel by super patron, consummate tube nut, and longtime supporter to the channel, and also camera shy, John the Pumpkinhead. Thank you, John. And my goal here was to make it compatible with a radio teletype, which is well known from ham radio operators, and it sounds like this. Still used today on ham radio. Of course, it dates back from the 1930s actually, to communicate with ships and planes. Frequency shift keying, so there are just two tones. Originally, I thought that all baudot machines that communicate with tones were compatible with each other, so I started with this one, which is a TTY for deaf people that want to have conversation over the phone. This is still made, and you can hear speaking baudot. But if you listen to these tones, they are different. These are lower tones. And it turns out that the Telex tones are also different. So there are three different standards for baudot teletype to talk over modems, and that's why we had to do quite a bit of adaptation to this one. We ended up having to redo another modem with the help of PCBWay, and we had to change some of the ROMs in the machine. What is interesting is that this one is probably the best single line editing terminal I have ever seen. I'm going to do shift clear, memory clear. Okay, I'm going to try to type without making mistakes. It says it is an intelligent keyboard. I managed to mess that up. No. This would be the second line, and it works. Yeah. Very well. Line, home, run message. And if I wanted to change the second one, I would go home, scroll, and it prints a few letters of the first line, so I know which line I'm on without spending the time of printing the whole thing. And then I press scroll again. I have the second line and scroll forward. This is not and then actually I'm going to go backwards. Another, and do shift scroll. Okay, forward delete, Shift scroll. And now I do home, run message, and that's where you would send it. So it's my final message. Probably the best interface I've ever seen for a single line editing on the teletype. But however, none of those machines are compatible with each other, so I have to modify each of them, see if I can remedy to that problem. My footage is a bit confused, but hopefully you got it. To go over the air or on ordinary phone lines, the baudot bits are converted into two tones. A tone for ones called the mark tone and another tone for zeros called the space tone. This encoding method is called frequency shift keying, or FSK for short. These two tones are immediately recognizable by ear, and although you'd think they would have standardized on two tones all over the world, they did not, so none of our machines are compatible with the RTTY tones, the US military and now ham radio worldwide teletype standard. For the electro-curious, here is my table of FSK frequencies used by RTTY Telex and TTY/TRS dev services. Note that there are 6 variants of the RTTY. The one we want to implement is the high tone narrow spread. To make things even more complicated, our Whisper Writer is a Telex machine. The Telex network was first introduced by Siemens in Germany before it grew to a worldwide network. And of course the Europeans would have none of that crazy 45.5 bit per second rate, or 45.5 bauds as it is known, that the US employed. Their teletypes worked at the more sensible rate of 50 bits per second, or 50 bauds. For this reason, European teletypes were not compatible with US teletypes. However, when Telex spread over the world, the 50 bits per second rate prevailed. Hence, our Whisper Writer, although it uses baudot teletype coding, uses the wrong 50 bauds rate of the Telex system. Long story short, if we want to make this baby compatible with over-the-air radio teletype, or RTTY as it is known, we have to change both its FSK tones and its baud rate. So Eric and I are back with our different baudot machines that are not exactly the same baudot and not exactly the same FSK encoding. Here we have the inside of the TTY, of the paper TTY, and we found out it has 3 processors and a modem card.
So it's got one processor that controls the printer, another processor controls the terminal itself, and the third processor is not on the circuit board.
It's on the keyboard, which is, I don't know what I did with it.
That's over here. So this is an intelligent keyboard, and not only does it do the editing, it also generates baudot code at 50 baud and then sends it into this terminal unit as well.
And here's our keyboard. I opened it up.
So it has the microcontroller, and then it has some logic that it uses to help scan the keyboard, and there's also a lot of memory on there.
Yeah, it's 4K, right?
Yeah, it's more memory than I've ever seen on a keyboard.
Yeah, and that's when we figured out that, man, that thing must have a pretty good editor, and it says 4,000 characters.
Yeah, it's the editing buffer.
And the modem, this one is all separate. So this should be easy to replace with our own version of the modem with the right frequencies.
Their own tone generators.
But I was panicked because I thought I would get a UART, and that we would just have to change the rate of the UART to go from 50 bauds to 45 bauds, and there's no UART. It's all done by this processor on here and
the keyboard.
And the keyboard. So at this point, I asked for help, and you stepped in, and we dumped the ROMs.
Yep.
And you tried to figure out how it was working, so we can change the rate.
That's right.
All right. And how many ROMs?
There are 3 ROMs total, but we only need to change 2 of them, I'm pretty sure. The one on the keyboard and the one for the terminal.
And these are Intel process? No?
Yeah, they're Intel.
They're Intel?
They're made by NEC, but these are 8049 microcontrollers.
So Eric, I dumped the ROMs, and then I just handed them over to you.
All three of them.
Yeah, figured it out, and it's 3 processors working together. And what did you do from there?
Well, what I did is I started with Ghidra, which is a reverse engineering tool. Mm-hmm. So it's a disassembler that lets you make comments and name variables and label locations and stuff like that.
So it ingests the
Raw
machine
binary
code, right?
Yep, direct machine code.
And out of that, it will give you the assembly code?
Yeah. So this is code here from the one in the printer controller, but this is pretty much what it looks like when Ghidra gets its hands on it. So you can see that it'll try to call a subroutine, but it doesn't know what to call it, so it just calls it by its address. And so here you can kind of look through, and it's disassembled, so at least you have an idea of what the instructions do. Mm-hmm. You just don't know what any of the labels are. You don't know what any of the subroutines do. Mm-hmm. And so you kind of have to go through and just look at it and understand what it's trying to do, and then figure it out from there. So I assume that they're using the timer interrupt to time the actual output data, the actual baudot data.
Which was reasonable because one of the receiver pin was connected to an interrupt line, right?
Right. But I discovered that when that interrupt fires, that means that there is data coming in, mm-hmm. and it actually synchronizes the timer to that incoming edge, which would be essentially your start bit. Mm-hmm. And then what it does is it waits for half of a bit cell at 50 baud, mm-hmm. and then it takes a sample. Mm-hmm. And then from then on, it waits an entire bit cell, grabs a sample, and then you're able to pull in all the bits for that data that way. One of the things they do is they have this timer preload register. And so you preload a number in there, and the counter counts up, because it's a count up timer. Mm-hmm. When it hits FF and rolls over to 00, then that mm-hmm. fires the interrupt. Mm-hmm. And so if you start at, for example, right here, they start at EC in hex. It counts from EC up to FF, and then it rolls over and resets, and then that fires the interrupt, and so then they set it back to EC again. And so by changing that number, you're changing how frequently that timer interrupt fires.
So if you put a lower number, it will wait a little longer.
Exactly.
And how many locations do you have to change?
There's not that many. I think it's only 2 or 3.
Meanwhile.
Okay, we're starting to get the hang of this Telex machine. When you turn it on, it's very picky. It says no carrier, but it's already sending a tone. We have actually hooked up a pair of speakers on the telephone line, so if you turn it on, Eric, and that's 1070 kilohertz or thereabouts. That's what it says over there. So what it wants before it does anything is a carrier, which is a mark at the F2 frequency, and that would be 2025. So we have it set up over there. Can you give us 2025 hertz? And now it has a carrier, but it still won't transmit. So for it to transmit, you have to give it a space. So you have to go to 2225. There you go. Now it's receiving, and now it's connected. You can see it's kind of blinky over here. Now if I do home run message, it's sending both those things at the wrong frequency, right? At the F1, F2 frequency. So it's all messed up because the wrong frequency, it needs a whole bunch of tone, and we want to change that. But I have made something that generates the correct tones over here. There you go. That's what we want it to do. And I have a transmitter and a receiver. You might have recognized the setup I use for the Apollo Quinder tones. Apollo 11, this is Houston, over. It uses the XR2206 as the FSK encoder and the XR2211 as the FSK decoder. This is pretty much straight from the application notes. I'll leave the final schematics in the doodly-doo. So the idea is to replace that modem card that has the F1, F2 frequency with that one over here, which has the RTTY frequencies. And we should be half the way there. So now I've pulled the modem board out, and from our previous experiment we think bringing pin 7 to 5 volts and pin 8 to ground should make it think it's connected. Also, we hope. Connected! It works! Alright, so we have fooled it. Let me check if our assumption is correct. This will be disconnected. That's correct. This is connected, disconnected. And this is carrier detect. No.
Maybe the line's floating or something. Could try grounding it.
No carrier. So we can just do this. Carrier is stored. Floating is good enough. And then we need 7 to connect it. Alright. So here we go. I have it full now that it's connected, and I connected it to my tone generator over here. So let's see if that works. Let's send a message. Alright, I think it sent the message. Okay, so I have now completed the receiving part of the modem, which is this chip, which is exactly the same chip, by the way, that's on this modem. It's an XR2211. Where is it? I saw it. Right here. And you can see the adjustment pots right here. But that's my own version of it at the right frequency. And if I send a message, so I think I'm decoding right, and to know if that's true, I'm going to put the output of my decoder over here, and we should now have a 50 baud RTTY if everything goes according to plan. So it did a line feed, and okay, so that tells me that I can now make a new RTTY modem for that machine. I sort of understand how to put it online, offline, and get it to work. So my only remaining problem is that now if I do the 45.5 bauds, and this is internet generated RTTY, I do decode it appropriately, but it's at the wrong speed. So when I put it in, you can tell it's decoding something, but it's completely wrong. Some kind of garbage character because it's the wrong speed. I need to make the modification on the ROM that Eric suggested and see if that fixes it. Eric's proposed modification of the ROM code is surgical. He tells me that I have to change just 2 bytes at the very beginning of the code, decrementing 2 locations by a smidgen to lengthen the timing. In the terminal ROM, EC at address 10 becomes E9 and EE at address 29 becomes EC. Or so he tells me. That's what good friends are for. Alright, so I'm reprogramming the ROM with the data I/O because my TL866 refuses to program my old proms. Except take it. Done. Okay, so that's good news. It supports 32K EEPROMs, and I've changed the other one in here also. Okay, we'll see if it still works. Now let's change the speed. 45. This Tono video terminal here is another gift from my good friends. It's an RTTY decoder that Antoine sent me from Europe. it can be toggled between 45.5 and 50 bauds, so we can get a quick confirmation if the ROM surgery did actually change the baud rate. 45. Yes! It's working at 45 bauds in that direction. Yay! So we are correctly sending at 45 bauds. We converted it. Eric did it right. So here's my receive. It's still screwed up. I'm getting something. There's some words. They, the US. So I think established views. So I think we are better, but we are not exactly at 45 bauds. Okay, so I started looking at the signal on the scope and it looked like the pulses were too short. So I changed a little bit the tuning of my decoding loop. And now all of a sudden, with that setting, it decodes the internet signal perfectly. Sensitivity testing indicates we may be 1.5 bauds too fast, something like that. It's a little bit on the fast side. So it looks like Eric got it almost right in the center the first time. It works. I just need to put this big thing on the PCB and we should be done. Okay, so I went ahead and designed a PCB with the new modem card. Ordered them for my favorite sponsor, PCBWay, and here they are. I just find it amazing. You just draw it on the computer and the thing comes back to the real world in a few days. It's a set of two boards. One replaces the original one, and then I have a little board for the interface components because there's many more plugs that I need to get to. So it has the jacks for the TTY and some for TTL levels, some from RTTY. Then I even made a little prototype area if I messed up, which I always do. Okay, so all finished. The card is tested, it works. I haven't tested the interfaces yet. It's going to be easier when it's in the machine. And now comes the hard parts to do the mechanicals, get all the holes drilled. I have 3 buttons to wire up and fit all that in the tight space. By the way, here are the glorious KiCad schematics, which I'll share in the doodly-doo. They are not exactly the ones I used to design the board, but I arrived at this after final testing. As expected, the proto area became pretty handy. After some testing, it got a few budge wires, mostly because I added functionality. So I added this relay to do loopback. If not, when you send RTTY, you could not see what you were sending. And then I added a rekey capability, which made use of an extra gate, so the extra area got used. And I'll demonstrate that in a minute, but it allows me to use this modem also for the regular teletype. Alright, so let's put it in the machine and see if that works. Alright, everything appears to fit. It's a little tight in there. I had to put a capacitor on studs so I could move it back. But apart from that, it looks almost factory. So my terminal has a few more capabilities and a few more control. It tells you if you receive signal from the radio teletype. It has a data blinking light. You can control the source for the printing. You have a transmitter control and you can go offline and online. And at the back I have labeled all the ports that it has gained. So 2 ports for RTTY, 1 for TTL, 2 for regular TTY high voltage 60 milliamp loop, a switch for control of the transmitter, and half duplex, full duplex for the TTY loop. That should be a full baudot testing machine. And amazingly enough, all the covers do fit. This one fits. this one. Also fits. Okay, I have it hooked up for the demo. So let's try its new RTTY modem. First on, we'll turn it online and show connected. And then if I turn on the RTTY stream from the interwebs, you can see here it's locked and I have data. So then if I listen to it, I'll get, oh, we're just in between messages when it goes N and N. There we go. There you go. So we have gained RTTY modem capabilities. Let's go into the transmit mode. And here I have my little RTTY receiver. And then you can use the local editor. And I'll send a little message that I have pre-recorded, a run message. It says subscribe to CuriousMarc's channel with a few characters too many. Alright, so that's the first capability that I really wanted to add, is something to do RTTY so I can test things in the future. But it can do more. So here's my trusty Model 15 teletype. And here's a loop supply, and I've plugged it at the back of my new Whisper Writer. And in the modem, I've included a driver for regular teletype. So the two are baudot machines at 45.5 baud. So they should be able to talk to each other if I set them up right. Let's do that. Put it into teletype mode. And let's turn on that. Let's send our own message. So I did send subscribe to CuriousMarc. Hello. I'll show you how it's typing it. So it works in that direction too. So I can use this as a source for both testing RTTY and regular TTY. But I've added one more functionality, which is to do rekey, which basically combines those two modems together. I am in a full duplex now. I have one transmit line and one receive line. If I give it some RTTY, so basically I'm using the two modems back to back, and I've made an RTTY decoder for this. Alright, and since it's full duplex, I can also do it in the other direction. If you hear it. Hello. Oh, made a mistake. So hopefully with this setting I can go on the air relatively quickly with the electronic one, and then switch over to the big TTY, and I kind of transform my telex in a universal baudot machine for a test. Alright, well, next thing we have to do is put it on the air.